Okay, so here we have a bunch of examples that are going to deal with percent predominantly. Are there other things in here? Yes. But it's percent questions so that we could practice percent. You could see percent questions in a different context. It's not always going to be, what is 20% of this number? You know, like, it's not always that simple. So we want to see a mixed variety. We want to see it, you know, in a weirder presentation so that we're ready for anything. By using the language I keep using, I do think it'll be most effective. It'll help you out. When I was calling on people today, it still didn't really matter. People still want to do it their way. That's fine. As long as you get the right answer, that's really what matters. But for consistency purposes, I'm always going to show you, you know, the same way in class, especially when we have like 30 kids in a class. So we want to be consistent. Okay. Here you have 3 questions that go to this data. We'll come back and look at the data in a second. Let's read the first question. A farmer wants to find out how many farms there will be in 2017. As soon as I read a number or anything mathematical, I find myself looking back at the chart. Now I see that the chart does not go to 2017, so my brain is telling me I'm probably going to write an equation that will predict what will happen because it's following a trend. By using a linear function, when I read the phrase linear function, linear equation, what equation am I thinking of when I'm talking about a linear function or linear equation? By looking at the choices, they're all sort of written in a certain style. They're all written in y equals, yeah, mx plus b form, okay? So that right there is sort of what they look like. Now, y might not be just y. Y we saw earlier this year, we could write it as f of x. In this case, instead of x, it looks like they're using f of t. So your input is t. And what does t stand for? In terms of the number of years since 1986. So t is the number of years since 1986. Now, do you have to go that crazy? No, I'm just highlighting all of it right now. So that's the T in all of these examples. Stands for the number of years since 1986. Okay, you don't want to do calculations. We don't mean to make ourselves crazy. Some people might actually try to figure out the slope here or something like that. You're wasting time. We should be able to narrow down our choices and just make a really good decision based on the information we have. Now, what thing are we trying to model? How many farms? How many farms? So where is how many farms in the table? Right here, total number of farms, right? Each year, what happens to the total number of farms? It does what? Decreases. So based on that, which choices do we cross out? Ones with what? Which letters? B and D, because they both have a positive S word, slope, a positive slope. M, that's your slope, also known as the rate of change, right? So it's the rate at which the farm population is changing. So now we've narrowed it down from a 25% chance of guessing the right answer to a 50% chance. From here, another thing that they mentioned in the problem is number of farms in thousands. They get you on this all the time on the SAT, in thousands. That means whatever number is there, you put the word 1,000 at the end of it. So here's my 2 remaining choices. They both have the same slope. Everything's the same except this number. In thousands means the number has really 3 more zeros at the end. That's really what that means. So what's the correct answer? C, and we're done. Next question, still talking about this table. What was the percentage increase? So that means if we have a percentage increase, we might have 100 and a certain amount P% in my problem. If you get, if you get 105, that means it was a 5% increase, right? That's what these things mean. What was the percentage increase in the area covered by sod in Canada from the year 1991 to the year 2006? Okay, let's look at the table. Here's sod, area covered in sod. So where's that over here? Sod, area is in hectares. And from 1991, it was this, until 2006, it was this. So there's my information, and I want to know the percent change. You have a bunch of ways that you can go about doing this. For consistent purposes, I'm going to do it the same way I've been doing it. The new amount is what per cent, cent means 100, of the old amount. And we just fill in. So what am I filling in for the new amount? 27,960. Good. Equals what? Well, that's what we don't know. X percent of means multiply, the old amount. 26, sorry, my 6 was a 7. 797. Okay, now, in the calculator, we're going to do some little math over here, get our answer. So, sorry, it's a little hard to see, but I'm going to divide both sides by what number first? Or maybe you want to multiply first, whatever. Which one do you want to do? Sure. What number do I multiply both sides by to start? Good. If you multiply by 100, multiply by 100, this 100 crosses out with that 100, it's a 1. Do I really even need to type that in the calculator? No, because it'll just add 2 zeros to the end of it or tack on 2 zeros. So times 100, I'm just for whatever reason typing it in. What do I do next?
Then you divide by 26,797.
Good. 26,797, 26,797. Divide by 26,797 equals, and we get this number over here on our screen, 104.34. So x is alone now, gone, equals 104.34. If that's the number that went above 100, to have a percent increase, it's what you add to the 100 for your answer. So what percent did we increase? 4% increase. We just round to the best answer, 4% increase. The main formula you got to know in order to do it is your new amount. New amount is what percent of the old amount. And then you just drop each thing into the equation, and that's it. So it's 104%, I'm rounding, of the old amount. So if we solved for what is the x? Okay, because we didn't know what that was. So we knew the new amount. The new amount was 27960. That was in the problem over here, 27960. That was the new amount. Then the original or the old amount, original or old, I'm just going to color coordinate it as best I could. Old amount that we didn't know, well, that's where that we started with, is that number over there. That was the old amount. They want to know what percent did we increase from that year to that year. Original was 1991. My new happened in 2006, right? My new amount is what percent of the old amount. So I didn't know what the percent was. I put in an X. Old I filled in right there, and new I put in that number. We solve, and we end up getting that X is equal to this number. If it's 104% of what it used to be, if you weigh 100% of what you weighed a year ago, I weigh 100% of what I weighed 1 year ago. You weigh exactly the same. But if you weigh 120% of what you weighed a year ago, you went up by 20% because you're all of what you were and you're 20% more. If you weigh 95% of what you weighed last year, you weigh 5% less than what you weighed. To be 100, you stay steady. You stay the same. You're maintaining. So because you got 104, they're rounding. They just chopped off this. That means you're 104% of what you were. So we kept that 26797, but we increased it by 4%. So it's a little bit more. So my 4% is my increase because I got a number 100 and something. Okay? So we'll see more of them as we go. What else?
Why did you cross out the hundreds? What do you just...
When I had the problem, I was here. So in orange, I'm circling how I started. Right?
Mm-hmm.
That's my new amount is what percent of the old. I multiplied both sides by 100. That 100's on top, that 100's on bottom.
Yeah.
So they cross out. It doesn't distribute to this. That's what we were talking about
there.
there.
Answer by multiplying the 26797 by 100 and then dividing the 2796 times 100 by that number.
You got 1.04.
Yeah, I got 1.04 and I said 1.01.
Right, but what you did is if you got that, then 1.04, if that was x in your equation, it would be up top. And that would be 1.04%, not 104%. Your brain just fixed it for you and automatically moved the decimal and you were okay. But really, because sometimes multiplying and dividing off by 100 or by 10, your brain autocorrects.
Yeah.
You're just like, I know what I need to do. But really, you have a little error in the work there, okay? The next thing over here, they're going to ask us about exponential versus linear. And I did mention that in each class. So a linear equation looks like this. That's linear. What else is linear? That's linear. If something's going up in linear, it looks like that. Going down in linear, it looks like that. If it was just data, linear data might look like this. Just random points. Linear data could look like this, just random points. But it's in a straight line if you connected it, right? Exponential data, like if you even think of these phrases, oh, the population was growing exponentially or the virus was spreading exponentially. Exponential is going to get more rapid as it grows, faster and faster and faster, so it curves and speeds up as it grows. That's exponential growth. Exponential decay, same idea, but it's getting smaller from left to right. It's decreasing from left to right. It's going down. And then the data will also have that look. It could be curved going up. It gets steeper as it goes up, or it could be curved and coming down. It's getting lower and decaying. So again, what does exponential look like? Let's highlight exponential in yellow. Is this exponential? Yes, it has this curve to it. That one's good. This one, and that one. The other ones are linear. How else can you tell? A lot of times, this is more ruled by like multiplication. Okay, there's this like multiplying factor over and over and over increasing or decreasing it. So you could be multiplying by a half or dividing by 2, or you could be multiplying by 2. Here, you're going to add or subtract a steady number every single time. All right. Here, just looking at this, is this data a straight line or is it curving? It's definitely curving. Normally, I yell at you, don't connect the dots. This is just the highlighter for me to show you the curve. This is very, very compressed. If I stretch that out, the curve would be even more obvious. So this data is exponential. A similar survey is conducted in China. So this is China. And the results are shown in the scatter plot above. Okay, there it is. Which of the following statements is an accurate conclusion based on the comparison between the two countries' greenhouse product growth rates? So here's China, and China is exponential. We agree?
Yes.
This is Canada up here, total greenhouse products.
It's linear.
That's linear. We said it's going up by how much every year or every 5 years? About 4 million? 4 million, 4 million, 4 million, 4 million, right?
Yeah.
So both China and Canada's production of greenhouse products is growing exponentially. True or false? That's out. We just said China, yes, China is growing exponentially. It says they're both linear, no way. China, linear, nope, that's out. China, exponentially, you're in. Here's the other one. Canada, growing exponentially, we said no. Canada, growing linearly, that part's fine. But China is not growing linearly, this is out. China, blah, 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 Canada growing exponentially. No, this is all sorts of bad. This, China's production of greenhouse products is growing exponentially, but Canada's is growing linearly. Oh, I cut it off. Sorry. Let me know if I do that again. Is that one good? Winner, winner, chicken dinner. That's it. Very little calculating to do here. Even if you had to guess on this question over here that was the actual percent question, if you had to guess, I guess you could take your old one, your old number here, and test it, but this is really time consuming. But if you were desperate, okay, you would take 2, 6, 7, 9, 7 times, if I want to increase, say, okay, here's a trick. If you're on the SAT and you want to do guess and check, always start with one of the middle 2 choices. So if I picked B, if I want to increase this by 24%, what do I multiply by? So you could either do 1.24 or really it's the same as 124 over 100. Equals 33,228. Is that answer too big or too small? Okay, it's too big. So if 24 is too big, well now these are all out. There's my answer. Right? If 24 is too small, now what can I cross out? 24 and A, 4. That's the benefit of when you guess and check, picking one of the middle 2. You'll always be able to cross out 2 or 3 answers, or you hit the nail on the head, you got it right. Question?
On the test or the quiz file, are we going to have questions when it's like, it's connected to 30, like, or one?
It might not be 3 pieces, because it's a little much.
Okay.
But, you know, it might be one question from it, but like, I wouldn't give you the other ones.
Wait, are you going in order to
I'm going in order of this packet.
next section that I mean,
Okay, if we don't get to it, we're going to move quick now. So if we don't get to it, you'll interrupt me in a little bit. Okay, right? Because you said what time? 3 what? Okay, we'll move quick. All right, we're here now. Radioactive substance. This is just using reasoning. I'm not having you guys like know from algebra 1, if you remember y equals ab to the x power. A is the initial value. If you forgot this, totally fine, okay? Not a big deal. A is the initial value, and B is known as your, this is throwback Tuesday, this is your growth or decay factor, they called it. Growth or decay factor. And you probably just did little baby problems with this when you did like banking problems. Do you remember doing banking problems, interest rate, and you plugged it into a formula? That probably happened. You with me, guys? Right, Ava? Yeah? Okay. So here, radioactive substance decays at a rate, annual rate, we said yearly, rate of 13%. Is 13% going to be important to the problem? Yeah, of course. Okay, 13%. If the initial amount of the substance, is 325 grams, well, where's 325? Here, 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 and here. Every choice uses 325, right? Now, not everything uses 13%. We see 13 here and we see 13 here, but is 13 being used in the problem elsewhere? What does 87 have to do with 13? Yes, it's 100 minus 13. So that means if I start off with 100% of the radioactive substance, I lose 13% of it. How much is left? 87% of it every year is what I keep. Every year, you're keeping 87%. You're losing 13%. It's chipping away. It's wasting away. It's slow, but it's happening. Okay, you lose 13%. You're keeping that. Which of the following functions F models the remaining amount? That's the important piece. Remaining amount. 87% remains. Remaining amount of the substance in grams T years later. Every year, you're finding 87%. You get an answer, take 87% of that. You get an answer, 87% of that. So what do you keep multiplying by in the problem? 0.87 or 87%, which means 87 over 100, which is equal in your calculator, I promise, to 0.87. Even as a decimal, that's tenths, hundredths, 87 hundredths, 87 hundredths, right? So that's what you keep multiplying by. So the choices with the 13 are out. If the 87 keeps getting multiplied, that's the one that gets the exponent, because the more you multiply by something, the higher its power, right? If you do 2 times 2, isn't that the same as 2 squared?
Yeah.
Or 2 times 2 times 2, isn't that 2 to the third?
Yeah.
So as you multiply by something more and more, it grows exponentially. It gets an exponent on it, so the right answer is? It's A, all right? Question on this?
Well, yeah.
Go ahead.
I just have another sheet that's ordered.
Say again?
My sheet that's ordered.
Oh, yes, you can take this. All right. I gave you one in class today.
Thanks. Yeah, but I already left them at campus.
Oh, okay.
I'm scared of her. No.
Girl, all you do is leave your stuff everywhere. Every day you come in. I left my phone, I left my notebook, I left my water.
She left all this out. It was rough.
A rectangle. Now, today I went over this in a lot of your classes the long way. I'm going to do it the cheap way right now. Ready for the cheap way? We love the cheap way. But the real way is important, but the cheap way is great. When we're doing these rectangle problems, the SAT loves them. What shape do we start with? Yeah, a square is still a rectangle. Totally fine. What dimension square should we do? 10 by 10. What's the area of it? 100. It's very easy to play with percents if it's a 10 by 10 and it's 100 area. So this is going to be my original rectangle. Not a great drawing, sorry. 10 by 10 are my dimensions. This can be my width is this side, my length is this side, okay? And my area is 100. There it is, beautiful, right? Now, new rectangle. A rectangle was altered by increasing its length by 10%. What's 10% of 10? 1. 10 per cent is 1 out of 10 if I reduce it, right? So 10% is 1 out of 10. So if I increase this by 10%, what's my new length? 11. If you did it in a calculator, the formal way, if you struggle and you're like, I don't wrap my head around this, the new amount is 110% of my old amount. You go on your calculator, 110 divided by 100 times 10, and you get the 11. Okay, I promise. Either way, that's 11. The width decreased by p%. So I don't know what this is, question mark. I'm just going to do it the cheap way, question mark. I don't know what it is. We're being real cheap. The area of the rectangle decreased by 12%. If it was originally 100, what's 12% means 100? 12 per 100. So if it went down by 12, the new area is how much? 88. You subtract 12. We want to know about this width. 11 times, base times height, length times width, right, is area. Length times width is area. 11 times what is 88? So that means my width will become 8. What was my width? Original width was? It went down by how much? Well, by what number first? Went down by 2, 2 out of 10. 2 out of 10 is how much out of 100? 20. So, final answer, 20, because they want to know, if these alterations decrease the area of the rectangle by 12%, what is the value of P? P is what we decrease the width by, what percent? That was the cheap way of doing it. Really cheap and easy. Not complicated, no formulas, no nothing. Question?
Does that work for any rectangle problem?
Essentially. Like, not like in life, like if they told you the dimensions of it originally, sure, that's different, because they might not ask you by what percent did it change. They might ask you how much did it change. Then you have numbers already. So you don't have to be like abstract. You don't have to be general. You'll have numbers. But when I do with the formulas, because I don't have numbers, I'm just generalizing. Okay? Okay, from here, Lincoln Park High School or whatever, Lincoln High School. At Lincoln High School, approximately 7%. So 7, what does per mean? Over, cent means 100, of means multiply. 7% of juniors, how many juniors? 562. And then we also have 5 per 100 times seniors. And how many seniors? 602. And I want to add those together because I read the problem and it says that's what was at the school. That many go into National Honor Society. Which of the following is closest to the total number of juniors and seniors at Lincoln High School last year who were inducted in National Honor Society? Now, two ways to do it. Calculator versus no calc. Ready? If I were to do this in a calculator, 7% of the juniors, you're probably going to type in 7% of means multiply, juniors, 562. Grab my calculator, type that in. 0.07 times 562 is 39.34. 39.34. Then, that's the juniors, so I'm going to put a little J. Now we'll do the seniors. Seniors is 5%, so point what? 0.05 of the seniors, which was 602, equals, and then I go to my handy dandy calculator, 0.05 times 602 equals 30.1. Now this number's already on my screen. These are my seniors. I'm going to add this number to my juniors, so plus right away, 39.34 equals 69.44. So together, 69.44. Okay, and which is the closest? None of the answers are going to be close to each other. Like, you're not going to be confused. Like, look how far apart they are. You know, you can't screw it up. See, again, your answers are always in order from least to greatest. So when you guess and check, not that you really could on this question, you start with one in the middle too. If it's too big or too small, you feed more than one bird with one scone. Right? Okay, now what if no calculator? Your calculator explodes and dies. Well, it's not that bad. If I ask, what is 7% of 100? What's the answer? Huh? What did you say it was? Oh, this is 700. I was like, why so big? Okay, what's 7% of 200? Good. 7% of 300?
Oh my gosh, 21. PEMDAS, my God.
How's that PEMDAS?
I don't know, I just say PEMDAS, right? The answer wrong. It's happening.
Oh my gosh, she's silly. Okay, so do you see it's every 100, it's another 7, right? For every 100, you have another 7. So, 7% of juniors, no calculator. You have 562 juniors. How many hundreds are in this group of juniors? 5 of them. So you have 7, 7, 7, 7, 7. How many 7s do you have? 7%. So 7 out of every 100. I have over 500. So at least 35, right? 5 batches of 7, so it's 35. Because it's 500. The 500, if I do 7%, I get 35. Now I have 62. Is that a whole 100? That's all I have left, right? That's not 100. I can't say 7. Is it half? It's a little more than half. So it's a little more than 7. A half of 7. A little more than half of 7. 4. Half of 7 is 3.5. So then what does this add to? 39. That's the juniors. Now for seniors. Now for the seniors. I have 600. Honestly, who cares about the 2? Right? Like, it's so small. Here we do 5%. 5 out of every 100. How many 100 do I have? So 5 times 6 is 30. So then I have 30 seniors, 39 juniors. How many students altogether? That's exactly 69. My answer is even more accurate this way than doing the calculator. The test is designed, they want you to not use a calculator. They want you to just figure it out. Okay, now for this robot over here, okay? The robot question. To compare the efficiency of different self-driving robots, researchers gave each robot 30 minutes to clean the floor. So they must put them all in the same dirty room. Put them all in the same dirty room, and they're like, okay, turn the robot on, time it for 30 minutes. Let's see how long it takes to clean the floor. And we'll figure out what % of the floor is clean after we're done. So these are all the different robots they tested. A Roomba, whatever brand, whatever. They took every single robot out of the store. Percentage of floor cleaned. How many of the robots were able to clean the whole room in 30 minutes? How many robots were able to clean the whole floor? Just one. Just this superstar over here, right? This is the best robot. This is the worst robot over here, right? This one only cleaned 30% of the room. Most of the robots cleaned half the room or more. Those 4 robots were terrible.
I have practiced at 3:30. I thought it was at 4.
All right. If the fastest robot, as soon as I read fastest robot, which one am I talking about? Right, the one that I just highlighted in pink, right? The fastest robot, this guy right over here, can clean the whole room in 30 minutes. It covers 15 square feet per minute. How many minutes was it vacuuming for? 30. They tell you up here, you have to read everything. So if it cleans 15 square feet in 1 minute, how many square feet will it clean in 30 minutes? How do you figure that out? Yeah. 15 times 30. Now, what if you're like, I'm not sure if I'm doing the right thing. I'm just going to multiply because my gut tells me that's what I do. 15 what? Square feet per minute. There's the per fraction bar. Okay? Then times 30. What's the units on 30? 30 was minutes. What happens to the minutes? Yes, it's beautiful dimensional analysis. 15 times 30, again, without a calculator. I'm going to do 15 times 2. Because 30 is 15 times 2. That's this. So I don't need to touch the calculator. I know 15 times 15 by heart. What is that?
225.
That's 225. Now double that. What's 225 times 2? 450. We said it was left with just feet squared. So that's square feet. That's how many square feet the room must be. Right? Now, there's more than one way to do this. I'm doing it the formal way. That's how many square feet the room is. That's my room right there. The slowest robot cleaned what amount of that room? 30%. Right. 30% of the room. The room is 450 square feet. Right? And how long did it take it to do that?
30 minutes.
In 30 minutes. So this is what it cleaned in 30 minutes. Now I could reduce. 0 from here and 0 from here are gone. In the 10, I have a 5, right? Or actually, I could do 30 divided by 10. What's 30 divided by 10? 3. And then what's 3 times 45? 135 square feet. So while this other robot, pink robot's done, cleaned the whole room, this dodo robot only cleaned 135 square feet. But that's not the answer. It's open-ended. That's how much it cleaned in the whole 30 minutes. It cleaned 30% of the room. That's how much. We want to know in square feet per minute. How many minutes did it take?
30.
So how do I figure it out? Divide by 30. And look at your units.
5 feet per minute.
Do you see that this units, though, is square feet per minute? It's literally what you need. The units tell you the whole story, like what you need to do. It's telling you the math. If it's square feet per minute, you're dividing square feet by minutes. That's what it's telling you. Then when you reduce that, we got 45. Okay, 45 square feet per minute. Now, there is another way to do it. Once a robot has finished cleaning the whole room, it starts over and cleans it again. In 75 minutes. Now, the fastest robot will clean the room more than 2 times in 75 minutes, right? What percentage of the floor would be cleaned twice by a robot with the median floor cleaning efficiency? What's median? The what number?
The number in the middle.
Sure, the middle number. The median, if you think of the highway, right? The median on the highway, where do you find it? In the middle. So the median is a middle number. Let's find the median out of this data. Ready? Smallest, biggest. Next smallest, next biggest. For the percentage. Next smallest, next biggest. Next smallest, next biggest. Got 2 more in the 80, 2 in the 50. Median floor cleaning efficiency. If I keep crossing off, 1 on each side, where will it be left? This guy right over here. 1 of these dots is in the middle, right? If you wrote out the numbers, a lot of people will write 30, and then they'll write 40, 40, 40, 50, 50, 60, 60, 60, 60, 60, and then a bunch of 70s, 80s, a 90, and 100, and then they cross them out until they find the middle. Have you ever done it that way? People do that. It takes way too long. So what's my median efficiency? 70% of the floor, right? 70% of the floor. So based on this information, if it cleans 70% of the floor is 450 square feet, right? If it cleans 70% of the floor in 30 minutes, what amount of square footage does it clean in 30 minutes? You could think of that. There's a couple ways we could do it. I'm going to kind of talk about it 2 different ways. So the other robot cleans 70%, there's 70% of the floor, 450, in 30 minutes, per 30 minutes. So what does it clean in 30 minutes? 0.70 times 450. Again, if I use fractions, it'd be faster. I'm just going to do decimals for now. So 0.70 times 450, 315, divided by 30. So this cleans 10.5 square feet per minute. How many square feet is the whole room?
450 or no, 900 now?
Mm-mm. The room is still 450 square feet.
Okay.
It's still that big. But now we have 75 minutes.
Okay.
If it cleans that many feet per minute, and we let it work for 75 minutes,
We do 787.
so what'd you do, multiply, right?
Yeah.
So you took that amount and you multiplied it by the number of minutes. Minutes cancels out, that's how many square feet you clean. How big is the room? 450, right?
Yeah.
Let's subtract out the room. What's left? That is the amount of floor it cleaned twice. Because it was on its second loop cleaning the room. The whole room is 450. We calculated that it cleaned 700, whatever it was, 700 something, 787.5. So this robot will clean 787.5 square feet, okay, in 75 minutes. Because here, it's 450 square feet, the room. It cleans 70% of the room. How long did it take? 30 minutes. So that's how much it cleans in 1 minute. 10.5 square feet per minute. Now, that means if I work for 75 minutes, times 75 minutes, minutes cancels out, times 75 minutes, minutes crosses out, reduces, and we're left with 787 square feet. That's what gets cleaned in 75 minutes. It's minutes right there. In 75 minutes, how big is the whole room? Still 450 square feet. So, subtracted 450 from that, and we got 337.5 square feet that was cleaned twice. So the answer, now, this will not fit in the boxes the way I have it. So, oh, but did it even want to know how many square feet? No. What percentage of the floor will be cleaned twice? What percentage of the floor? How can I figure it out?
I'm lost. Are we dividing 77.5 by 75?
No, I wrote a sentence though. I just said 787.5 feet squared is clean, square feet, in 75 minutes.
So how did you get to 300 and...
Because I want to know how much of the room is cleaned twice. The room is 450 square feet. So I subtracted 450 from this. I took out the room once.
Okay.
That left me with this many feet extra, square feet extra. So this is the room. The robot cleaned. That's 450. Then it made its way back, and it cleaned this twice. What was this? 337.5.
Okay.
Because that's how much it could clean in the time. So this amount of the room was cleaned twice. But they want to know what percent of the room was cleaned twice.
Gotcha. Okay.
So that's what's cleaned twice. That's the whole room. What percent of the room is cleaned twice? What do I do?
Divide 337 by 450.
Yeah, you can think of it like a test grade or a quiz grade, right? So we're going to do it this little lazy way. Divide by 450. 75.75. Now, ignore the percent sign when gridding. 0.75, really what you'd have to do is times 100, right? To say that it's 75%, because it's 75 hundredths. 75 as a decimal, 0.75 is equal to 75 over 100. So your real answer that you would bubble in is, well, ignore the percent, so 75. Winner, winner, chicken dinner. Are there other ways to do it? Yeah. I'm just breaking it totally down for you guys so we see every aspect of it. Next. This one's not so bad, I don't think. Did you try this one yet? Not yet. If half of the 4,600, half of, translate math, what does that mean? Half of, right? Literally. Half of 4,600 spoken languages in the world have writing systems. What does that equal? So that's how many languages have writing systems, right? Have writing systems. WS, writing systems. Okay. Now, oh, sorry, I'm cutting it off. 23 of those, so 23 of these use Arabic script. What percent of writing systems use Arabic script? You have options. 23 out of, 23 per 2,300. Reduce the 23s into ones. 1 over 100, right? Which is what percent? 1%. But what did everyone do? And they were calling me over and throwing a fit. Ready? They were like, I don't get this, because what did they do? 23 divided by 2,300, right? That's what everyone's going to do. Their way. They get this, and they're like, it's not there. But you have to read the question. It says, what percentage? That is, how do you read this decimal as a number when you learn in elementary school? That is one, whoops, whatever. That is one what? One, sorry? 1 out of 100. Which is 1%. Cent is 100. That is 1%. You can't, they're confusing you because they wrote it like this. Do you see how they wrote these decimals? They know what they're doing. They're being mean. Because what are people going to pick? A. Right? But what's the answer? C. It's 1%. They are messing with your head.
And also, that would be 10%.
Yeah, that's 1%. That's a tenth of a percent. It's less than 1%. It's teeny. Teeny tiny. Could that be an answer? Yeah. Not here, but it could be. Okay? Now, if you said the formal way, 23 is what percent of 2,300? you will get 1 in the calculator. Instead of doing it, you all like doing it this way, dividing and just doing it that way. But if you did it the word way, if you multiply by 100, what do you get on the side? 2,300. And then you divide by 2,300, so what do you get for x? 1. Like, you won't mess it up.
Yeah.
It's like impossible. You know, like if you just follow the language, you'll always get it right. Okay? Next, do you see how this is set up? Now, you guys don't really know much about this yet. We'll learn about this later this year, but I figure let's get your feet
It's
wet.
gonna be on the test.
Not like where I would expect you to know this, but honestly, you could narrow down the choices. It's really, you don't even need that next lesson to get it right. Okay? You want to guess C? Anybody have another guess? What would your second guess be if I told you C was wrong?
D.
Okay. Do you guys agree with her?
I haven't read the question yet.
All right, so let's read it and then you have to tell me if you agree. Ready? Oops, over here. In planning maintenance for a city's infrastructure, so infrastructure like dealing with your roads, your bridges, your tunnels, your traffic, everything that's going on, your subways, your trains, a civil engineer estimates that starting from present, the population of the city will decrease by 10% every 20 years. Now that already, what does that tell you? Decrease by 10%. What's probably going to be in the problem? What do you think? We're dealing with how many people are left.
Yeah.
Say what?
Wouldn't it be the 0.9?
Yeah, I like the 0.9, right? 0.9 because it's 90% remains, right? So it's 100 minus 10. That's where we get this 90%, which is also equal to 90% or 0.9 or 0.90.
So we automatically cross out 1 A and B. No.
Those aren't looking good, right? I will get rid of them. Process of elimination. So Jen's answers look good. She has the 2 most reasonable answers on her list. If the present population of the city is 50,000, I mean, they all have 50,000 right there. Guess that's where it goes, right? Like, even if you didn't know, now you know, okay? Which of the following expressions represents the engineer's estimate of the population of the city T years from now? Here's how you do this. Ready? This is not the full lesson. But there's the 20. Ready? The population is going to go down 10% every 20 years. How long will it take for it to go down 10%? Okay. If I plug in 20 for time, look at my choices. Do you take 90% of it? What's 20 over 20?
1.
1. So that means you're going to take 90% of it one time after 20 years.
Okay, that makes sense. The other one's like 400.
Because then, yeah, you're going to take 20%, 90% of it to the 400th power. So that means you took 90% of it 400 times. So that's why you end up dividing it. So it's a little weird. So the best way to do it is take that number and fill it in. If it's every 20 years, that means 20 divided by 20 is 1. In 20 years' time, you only deducted or decreased it by 20% or 10% once. So I do like choice D. Okay? Do you see that little division step they threw in there? This would be if
20 years looks like a coefficient. Which what makes funny with
right, and it looks good and people like it, but what it's doing is it's really increasing it. So this is like saying it decreases by 10% 20 times a year.
Okay.
So in 1 year, you plug in a 1 for time, 20 times your population decreased. So like every X amount of days, that ended up being every 20 times a year, that would be what we use. So in 1 year, you did it 20 times. You know, like if you get paid monthly, once a month, you get 12 checks a year, well then you might have a 12 in there because you're doing it 12 times a year.
Yeah.
So it's like increasing that frequency. But if you're dividing the frequency out, like it's not every year, it's every 20 years, it's going to be there. We'll have a formal lesson on it, but when you're desperate on a test, you see how I just reasoned it out by plugging in 20.
Yeah.
So plug in this big chunky number, especially one already mentioned in the problem, to reason it out in your head. Take your time. Yeah. Okay, here. Now they're going to feel like they're going to start moving faster because I feel like you'll have like a rhythm going. In State X, Mr. Camp's 8th grade class consisting of 26 students was surveyed, and 34.6% of the students report they had at least 2 siblings. So that means you could have 2, 3, 4, whatever, right? The average 8th grade class size in the state is 26. He had a class of 26. The average state class also is 26. If the students in Mr. Camp's class are representative of students in the state's 8th grade classes, and there are this many 8th grade classes in the state, if there's that many 8th grade classes, and on average that many kids, can you figure out how many 8th graders there are on average, typical? You have this many 8th grade classes, and about that many kids in each class.
Oh.
Right, you could probably multiply to figure out how many 8th graders there are, right? So, if I want to know how many 8th graders there are, I might do 26 times, right? That's students per class. Look at me doing dimensional analysis again. Times 1,800 classes. What reduces? classes, and we figure out how many students. There's dimensional analysis again. So yeah, what was it? 26 times 46, 800? Oh, is it one of mine, little ones?
Yeah.
It's the solar power, it's too dark in here.
Can you cross out D? Because that would be 100% of
Yeah, there you go. Exactly. Check in. That's all the kids. Now we want to know 34.6% is about what amount? Like half of it, a quarter of it. What that percent is almost like
It's closer to a quarter than a half. It's like a third.
a third. That's what we're looking for. It's about a third. It's about 33.3, almost. A third. So C is like 2/3, so it's almost, 30 out of 45 if I was rounding. You're out. This is 1/3 of it. That's the kids who have at least 2 siblings. What is the question asking for? Fewer than. Right, so it is B. Sorry, I was like jumping the gun there. So it is B. Fewer than 2 means 1 or none, right? That is that amount. If that's 1/3, 1/3 of the kids, which is that amount, or where am I? Yeah, 1/3 of the kids is that number. That's what I found. But I would subtract that from the other amount. I could have also flopped it around. This number, at least 2 siblings, goes with that. So the answer is B. Sorry, I kind of like inverted it when I was doing it. I did the wrong question. Good? Shoppers enter a store. I did this with one of the classes. Whose class did I do this with? Period. None of you guys, right? Okay. Shoppers enter a store at an average rate of R shoppers per minute, and each stays in the store for an average time, average time of T minutes. The average number of shoppers in the store N at any one time is given by this formula. The relationship is known as Little's law. Okay, sure. You don't even need to know what this is about. You're just gonna plugging stuff in. Just let it be. Okay? Do not overanalyze it. They give you these formulas and you're like, what the heck are they even babbling about? Don't worry. Just follow the formula and plug stuff in. So the owner of Good Deals store estimates that during business hours, an average of 3 shoppers per minute. Look at the units. 3 shoppers per minute. R shoppers per minute. That's R. So the units tell the whole story, okay? 3 shoppers per minute enter the store, and then each of them stays an average of 15 minutes. What is that? T minutes. What is that? T. The units tell you the entire story. What else do they tell you? The store owner uses Little's law to estimate that there are 45 shoppers in the store at any time. Over here, N is the average number of shoppers in the store at any one time. N. Okay? Here's an example at the top. Now we have our own example to do. They set you up, and then we follow from there. They did a full example for us. They showed us how it worked. If you fill these in, N, 45. R, 3. T, 15. What's 3 times 15? 45. Got it. Totally works. Now, Little's law can be applied to any part of the store, such as a particular department or checkout lines. The store owner determines that during business hours, approximately 84 shoppers per hour. Now, it's almost right. What's wrong with it? Right. If it's 84 shoppers per hour, let's bust out our dimensional analysis again, right? How does that change to minutes? 84 shoppers per hour. How do I make it minutes? 1 hour on top. Beautiful. Now, hours is gone. 84 divided by 60. 84 divided by 60. And what do I get? 1.4 shoppers per. Right. Now, could you leave it, if it's a non-calculator, just leave it as a fraction? Yes, but we have our calculator now, so we'll use it.
How many questions are going to be on the quiz tomorrow?
8.
Is it enough to take 25 minutes?
It should take you like 15. It's not trying to be crazy. So 1.4 shoppers per minute, there's my yellow, right? That's my R. So if you want the little R with it, whatever you want to do, that is R right there. Now we keep reading. Make a purchase, and each of these shoppers spends an average of 5 minutes in the checkout line. What's 5 minutes then? Is that something for our problem?
No.
Look up top. T minutes. Yeah. They said we could apply Little's law to a part of the store, not just the store. So 5 minutes is T. 5 minutes. So T equals 5 minutes. That's it. From there, at any time during business hours, about how many shoppers on average are waiting in the checkout line to make a purchase. So what are we solving for? N. Well, all you do is fill it in the formula. That's it.
Just 1.4 times 5.
So N equals 1.4 times 5. Now, if you did not have a calculator, if it was non-calculator, this number, 1.4, would have been 14 tenths. And 14 tenths times 5, do you see that 5 and 10 reduce and give you a 2 on bottom, and you get 14 over 2, and you get that same 7 you get from the calculator. Okay? So the answer to this question, 7. Next. The owner of Good Deal Store opens a new store across town. For the new store, the owner estimates that during business hours, an average of 90 shoppers per hour, and the underlined hour, again, we should fix that, right? 90 shoppers per hour, and you guys told me I had to do what to change it to minutes? Divided by 60, 60 minutes, 90 divided by 60. Now let's try to do it without a calculator. What does that reduce to? 3 over 2, good. 3 over 2, and hours crosses out, so 3 over 2 shoppers per hour, just abbreviating, and that is yellow, which is my rate. 3 over 2 shoppers per hour, and each of them stays an average of 12 minutes, so T equals 12. Now, I didn't even finish reading.
For R, isn't it shoppers per minute?
Oh, minutes right minute, thank you. We just changed it, I know, I still did hour for some reason. Thank you. So 3 over 2 shoppers per minute, and then T is 12 minutes. Now, I didn't even read the question. I'm only right up to here. Can I figure out N?
Yeah.
Sure. N equals R times T, 3 over 2 times 12. 12 and 2 reduces, I get 6. 3 times 6 is 18. So N is 18, and the units for N is shoppers, average number of shoppers in that store or area. So 18 shoppers are in this new store at any given moment. The average number of shoppers in the new store, which we already got, we didn't even finish reading. I like to solve as I go because the question sometimes makes it more confusing. You don't know where to start. But if you can just do little bits as you go, like trust your instinct, like, well, I have R and T, I should probably find N. You know, like, do it. 18 shoppers, so that says the average number of shoppers in the new store, 18, is 8, again, we're translating, right? 18 is, I'm following the words, what percent, X percent, less than the average shoppers in the original store at any time. How many shoppers were in the original store at any time? No. Original. This is in the checkout line. How many? It was in the, all the way up here. Yeah, 45. 45 shoppers. This is in the checkout line down here. That's not the same. So it can't be 7 because 18 is not less than 7. Right? Like the question would make sense. So that would be a red flag. Like you'd be like, wait, what? So that's gonna like throw you out, like throw you off, mess you up. So 45 shoppers, that's the original store. 18 is what percent of 45, and then I'll figure out what percent less that makes it. Multiply by 100. Now what if I don't even fully multiply? Here's times 100 on the side, times 100. Cross out, calculator free, way to be. Divide by 45. What do 18 and 45 have in common? What else? Bigger, 9, right? Cross out a 9 from each. What's left? 2 and 5. Can 5 reduce with 100? 20. 2 times 20 is 40. Now, 18 is 40% of 45. So what percent less than the original amount? It's 40% of it. 60% less. 60 is the answer. But you see, not everything is going to be like, what is 4% of 28? Like, not every problem is that easy. And if that's all you can do, then you're going to be in rough shape. What else? Go ahead.
Confused about where we got the 60. Like, I understand.
So, okay, so this says, I'm going to highlight in here, 18 is what percent of 45?
40%.
So 18, the number of shoppers in the store, is 40% of the original amount. But the question is asking you, it's what percent less than the average. So if it's 40% of it, so if I weigh 40% less than what I used to weigh, I weigh 60% of it. You know, it's like a flip-flop. You have to find that inverted number. So it's like, what did you retain or keep, and what did you lose? So it's like, we're 40% of what we used to be, which means I lost 60% of my shoppers. Because I only have 40% of what I would normally have. My values, my numbers are 60% lower for my shoppers in my store. Okay? All right. Here, let's see what happens if we don't read this and go right to this. If we can work backwards. Ready? If a 9th grade student at the high school is chosen at random, which of the following is closest to the probability that the student will have a GPA of 3.0 or higher? 3.0 or greater, enrolled in Propel and not in Propel, who cares? These are ninth grade students. How can I figure out how many kids go to the school? Add what? All of it. Well, how many ninth graders go to the school, right? If I add all of it, sure. Could you do that? Absolutely. What do we get? 61 plus 48 plus 95 plus 1, 2, 3 equals. Now,
Why would you add all four of them together?
well, these are kids that are high GPI, low GPI, well, higher, lower, enrolled in Propel and not in Propel. But these are all ninth graders.
It's like people in the smaller community and people not in the smaller community.
Yeah, but
They're also
would,
minor.
okay, I know, but like, wouldn't,
No one could be in two groups at the same time.
yeah, so isn't that the similar with like, does you mean you can't like double dip? Like if you don't have a 3.0, then that means,
You're then in this group.
yeah, you're not group, so the two of them together, it's like either or. So like,
Right, but then this is Propel or not Propel. So it's like these are kids who take Spanish and don't take Spanish.
But you do two separate percentages and you add them all up together.
All I'm doing is adding the number of kids. So it's like saying pretend Propel is play a full sport.
Okay,
So the kids who have a 3.0 or higher, 61 of those freshmen are freshmen that have a 3.0 or higher and play a sport.
okay.
Of the 3.0 or higher, 95 don't play a full sport. Less than 3.0 though, 48 kids play a full sport and 123 don't.
So you're trying to find the total amount of kids in the ninth grade?
Yes.
That says it.
I know, that's why I was going to show you that next. So when you don't read that paragraph and you do it this way, could you get the answer? Yes, but where is it? It tells you right here, 327 ninth grade students.
It's so kind of confusing.
So if you're talking about, I mean, really any one thing, but I'm just going to pick a piece of scrap paper. So making something up. Ready? What grade are you in, junior?
Yeah.
Okay, so juniors, right over here. Okay, juniors who take honors algebra 2, and students who don't.
It's about
Students who take honors algebra 2 and students who don't are here. And then let's even do female and male, whatever. No one will be
Different, okay.
in overlap.
Gotcha.
So when I find out, okay, there are 90 females who take honors algebra 2. There are 80 males who take honors algebra 2. There are, 198 females who don't take honors algebra 2. There are, whatever,
Oh, okay.
79 males who don't take honors algebra 2. This is all the juniors
Gotcha.
all together. Like you can't be in two things at the same time. It won't work. Okay? So if they're in Propel, whatever this program is, they either are or they aren't, and they either have a 3.0 or greater, or they have less than 3.0. You can't possibly be in two groups at the same time.
Okay.
You're either here, 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 or here. Okay? All right. So that's all the kids. If ninth grade student is chosen at random, so eeny, meeny, miny, mo, how many students am I choosing from?
Oh, sorry.
327. What is the probability the students will have a 3.0 GPA or greater? How many kids have a 3.0 or greater?
61.
61.
The sum. Both of these.
What?
They all have it. These are kids in Propel with a 3.0 or higher, and those are kids not in Propel with a 3 or higher. So that 61 plus 95 is that total out of 37. Oh, not 37. Kidding. I can't do math. 61 plus 95 divided by, divided by 327. Now, percent, so times 100, 47.7%. B. That's it. Got it? It's that really that many, okay? If I added those together right off the bat, 61 plus 95, that was 156, right? 156 is what percent of 327? You get the same answer, okay? Probability though, when we're dealing with percent's on a scale of 0 to 100. Probability is from 0 to 1. It's the same numbers, just divided by 100. So probability is the same as percent, just divided by the 100. It's just left below as a decimal. What's the difference to the nearest whole percent between the percentage of students enrolled in Propel who had a GPA of 3.0 or higher? Hold on, a lot of information. How many students are enrolled in Propel and have a 3.0 or higher? 61 kids. All right, that and that at the same time is 61 kids. And the percentage of students not enrolled in Propel who have a 3.0 or greater. How many of those are there? Not enrolled in Propel who have a 3.0 or greater. You just told me it was what, 95? So what's the difference to the nearest whole percent between the number of students enrolled in this and enrolled in that? So how many students is the difference? They really use the word difference right here, right? Yeah, difference means subtract. So if I subtract those, I get 95, take away 61 is? Difference. Guys, calculator. Oh, There's 34.
I wanted to say that, but I was.
A little too tired now.
Just not
To the nearest whole percent. That's not the percent, that's the difference. Enrolled in this. So where do you think we're going to compare this 34 from? 34 out of how many? Percentage of students. That part right there is talking about like all of the students. Then they're describing enrolled in Propel, who had a 3.0 or greater. That's one batch. And then not enrolled in Propel, who had a 3.0 or greater. That's another batch, but it's like the percentage of students, not the percentage of 3.0 or greater students, not the percentage of Propel students. So they're generalizing percentage of students. So it's this number out of the entire 327. So 34 is what percent, you could use X as the whole thing instead of being over 100, of 327. Divide by 327, we get that same thing back, that 34 over 327. The calculator will show you this, 0.1039, whatever, but it says to the nearest whole percent, 10%. Last one of these. Of the students enrolled in the Propel program, which of the ratio of boys to girls is 2 to 3. Keep in mind, side note, 2/5 is the boys population and 3/5 is the girl population in that group. Do you see what I mean? So for every 2 boys, there's 3 girls. That means 2 out of 5 are boys. It's a little awkward. So these are comparing 2 parts of a whole. Which of the following is the best estimate for the number of girls enrolled in the program? So Propel program, how many students are in Propel?
61.
No.
Enrolled in Propel. Oh, 109.
Yes, 109 are in Propel. Then we want to know, say it again.
Should you divide that?
So there's a couple ways you could think of it. If you just think of it, we want to know how many are girls. Think of the words again. 3/5 of the students are girls. Right? Like, you don't have to divide by 5 and multiply by 3. I know your brain can like chop it up like that, but if you use the words, you're literally going to jump right to the answer every time. 3/5 of the students in Propel are is another way of saying is. You are, she is, right? It's a form of the verb to be. Are girls. She are. You is. 3/5 of 109.
That's 65.
So 65.4, and it said to round to the nearest.
You didn't have like 4 other persons.
Yeah, that's crazy. Unless someone has an extra arm or something. I don't know. Okay? This one over here is just, it's no math, it's just reasoning. And everybody's going to read into it. So when you get a statistics question, if you guys are juniors, whoever one of you are, a polling agency recently surveyed 1,000 adults who were selected at random from a large city and asked each of the adults, are you satisfied with the quality of air in the city? Of those surveyed, 78% responded that they were satisfied with the quality of the air in the city. Based on the results of the survey, which of the following statements must be true? Of all the adults in the city, 78% are satisfied with the air quality in the city. No, we do not know that. Approximately 78, maybe.
Wait, I'm sorry. Of those 70% of people that they're satisfied with. But why would that not be correct?
Because we surveyed 1,000 adults.
Not all of them.
But we're not saying which of the following must be true of all the adults in the city. If another 1,000 adults selected at random from the city were surveyed, 78% of them would report that they were satisfied.
No.
No, you cannot guarantee that. If 1,000 adults selected at random from the different city were surveyed, 78% of them would report that they were satisfied with the quality of the air in the city. You cannot guarantee any of them. None. None. In a scatter plot of this data where renewable energy consumption in the year 2000 is plotted along the x-axis. Do you see I'm writing as I go? I don't ever want to read the problem entirely and then try it.
Wait, I still believed it. Now
It's got a bar graph on top.
oh, like,
Okay, do you see, like, I put the info on as I read it because I don't want to read it twice. No thanks.
are you recording this, Steve?
Yes.
Hi, people.
2010 along the y-axis is how many data points would be above the line y equals x? Y equals x is a relation. We talked about relations this year. It's a relationship where x and y are equivalent to each other. So, like, if biofuels is equal to 0.25, then so it would be in both years. Okay? Dark one is 2000, the lighter one's 2010. I'm sorry, cutting off. 2010. So if I plotted biofuels, when y equals x, it's right down the middle. In 2000, I move over 0.25, but then in 2010, I have to move up almost 2, right? 0.25, 1.8. Over 0.25, up 1.8. There's the dot for biofuels. Oh, yeah, I have it on there. So that dot is for biofuels. They're not equal, so the dot landed on a certain side of the line. If it's on this side of the line, that means 2010 was higher than 2000. You went over 0.25, up 1.8, because this is 0.25, that's 2000, and then that is 1.8, that's 2010. My x-axis is 2000, because it told me to. My y-axis is 2010, because it told me to. That's biofuels. The next one, I'm just going to do color dots so it's separated. They're almost equal, but do I land under the line or above the line for geothermal? I move over and I move up. Which one do I do more of? Move up or over?
Over?
The dark is the over.
Oh, okay.
It's 2000, do you see?
Yeah.
This is 2000. It's how far I move over. 2010 is how high up I go.
Okay.
So I'm moving almost the same amount, but I go up a little bit more than I go over. I mean, it's not the right number, so I'm just putting a dot on here to kind of represent it. The next one, hydroelectric. Do I move over to the right more or do I move up more?
You move over.
Right. So I move over quite a bit, but I don't move up quite as much. So I'll end up under the line. Okay? Under the line. The next one, this orange guy, wind. I move over barely anything, but in 2010, I have a lot. Move over barely anything, and then I move up quite a bit, whatever it is. You know, I move up more. I don't care. It's just above the line. I'm being a little messy. And then the last one, wood. I move over 2000 quite a bit. I move up. It's almost like the hydroelectric, right? Hydroelectric was almost the same idea. I move over and up, but not enough to go above the line. How many points end up above the line y equals x? How many are below? 2. How many data points would be above the line? 3. The line y equals x is called the identity function. It's where they're equal. So if you had a bar here and here next to each other that were the same height, that would land on the line because you would move over and up the same amount, right? 0.5 and 0.5 or whatever it is. Then you would land on the line. Anything that the second year is higher would land above the line. Anything that the 2000 was higher would land below the line because you move over more than you move up. So this would mean these resources are being used more. These are being used less. What's being used less? Wood and hydroelectric, which is kind of sad. Hydroelectric I feel like should be used more, right? Biofuels in 2010, that was very high. I don't know, is that a good thing or a bad thing? Wind went up, but probably should go up more. Of the following, which best approximates the percent decrease in consumption of wood power in the United States from 2000 to 2010? Okay, what was the wood consumption in 2000? 2.25.
Sorry, 2.2.
You see, you always gotta look at what they count by because they really mess you up, you know? 2010, what was the wood?
2.
Okay. This is the new amount, or no, this is old amount, right? This is the new amount. So, using my words, the new amount is what percent? Let x equal the whole percent. What percent of the old amount? Divide both sides by?
X. Oh no. Divide both sides by 2.25.
So 2 divided by 2.25. That's the percent, 88.888, right?
Why don't you divide them by 2.25?
Divide, say it again.
Why wouldn't you divide both sides by 2.25?
I did.
I think you said multiply.
I thought I said divide. I don't know, I'm tired too. 2.25, I think I said divide. I did divide in the calculator, see?
Yeah, okay.
So then I get that x is equal to, I just rewrote it the other way, 88.888. If I change it to a percent, hundredths, it's that. Which is almost how much percent?
89.
Almost 89%. So it's 89% of it. So what best approximates the percent decrease?
11.
Yes. Done.
I feel like that's just, if I ever get an answer where I don't think it's right, I'm just going to subtract from 100.
I mean, if you're desperate, yeah, you will get the hang of it.
Yeah.
You know, that's why I figure I'll show it to you guys now, earlier in the year, so that like as they come up and present themselves, these percent questions mess everyone up and they sneak up all year. I'm like, let's make a little interruption and do some percent. Because I did, look, it was, I mean, how confused are people? Everyone's doing it different ways. People are getting different answers. The word problems are hard.
Can you pause that for a second? I was supposed to like, okay.
All right, here we have single level and double decker, in service less than 10 years, in service 10 years or more, cars on the railroad. Okay, the table above presents information about 810 train cars in service on a railroad. If we add those up, it's going to be 810. That's why it benefits from reading the whole problem. Approximately what percentage of the train cars in service are double decker cars that have been in service for less than 10 years? Well, it's 16, but not 16%.
So 16 over 810.
16, so if we do it the long way, is what percent of 810? But yes, essentially it's 16 over 810. Now what if, again, your calculator's broken, right? 16, 810, well, what could I compare it to? Maybe I could compare it to 15 and 80 if I wanted to make the numbers like, rounder.
Closer to 81, and that could also be sort of 18-ish.
Or 18 and 81. These both divide by 9. What do I get? 2 out of 9, which is 1 out of, I lost the decimal. I lost the 0. So 2 out of 90 is 1 out of 45. 1 out of 50 is what percent?
2%.
Right, so 1 out of 45 is about 2%, so I would guess that. But obviously if you have a calculator, you could still do it. That was just us being calculator free. 16 divided by 810, 0.0197, so about 2%. All right, the population of squirrels in a park has been doubling every 15 years. What kind of growth is this? Exponential growth. Which of the following statements best describes the type of function that best models the relationship between the population of squirrels in the park and the number of 15-year time periods, blah, blah, blah. Okay. So, right, they're not linear growth. So again, eliminated. So we quickly learned by just doing this one packet, like how many new skills do you have to like chip away at choices, right? Exponential growth, because the population of, look, I'm comparing, squirrels is increasing by the same amount, by the same percentage. Is it by the same amount or same percentage if it's doubling?
By the same percentage.
If you keep doubling the population,
Then it's not the same amount.
Same percentage.
right, you're going up by 100% every year. So, B. Go ahead.
So for the one that we did earlier, and we were doing, let me see if I can find her. For number 28, like where it was sort of comparing, like every 20 years, how would we write that? What would it look like if it said it doubles every 15?
Okay, so if we had to write the equation, which they didn't ask us to do, but that's fine, it would be y equals ab to the x is that format, right, that I brought up before. A is the initial amount. So I don't know how many squirrels were in the park originally, so I'm going to call it I for initial amount. Okay, y is the amount of squirrels later. If you're doubling, okay, if you go up by 5%, you would do 1.05. If you're doubling, what percent are you going up by?
To
100. And what's 100% plus 100%? It's 200%, so you would put a 2. Every 15 years, so here's your time. If it's every 15 years, it's time over 15.
Oh, okay.
Because in 15 years, it'll double once. In 30 years, it'll double twice.
Okay.
In 45 years, it doubled 3 times. So this doubling happens every 15 years once.
Okay.
30, 45, 60, it'll make sense that way. That's the initial amount, how many you started with, and that's how many schools we have. And then this one, for a certain reservoir, the function f gives the water level f of n to the nearest whole percent. So f of n tells you the percent. On the nth day, so n over here is the day, of 2016. Which of the following is the best interpretation of f of 37 is 70?
On the 37th day, 2016, the water level was 70.
Yes. The day is here, 37th day, and then your f of that whole expression equals the percent. So equals 70, and then the end.